Hey, Mr. Lee here. Here's your Khan Academy tutorial for graphing quadratics in factored form. Okay. So keep in mind, I will be using a calculator um, to get some of these y values for this graph. So just it might be handy just to have a calculator on hand. All right. So it says graph the equation. Here's your quadratic function. We're in factored form. If you eventually multiply this out, you'll see the x squared. That's why we have a parabola. Okay. So 1 point controls the vertex. 1 point controls just another point on the parabola, but then, as you can see, it will create symmetry, right? There's always going to be symmetry with these parabolas. So first thing to do, we're in factored form, so let's find the zeros. Okay, we should be able to find that easily. Um, if you have an x value of -5 plus 5 is 0, 0 times anything, this whole thing goes to 0, okay? I don't care about this fraction because 0 times anything is still 0. So just for now, I'm going to put a 0 on -5, and I'm also going to put a 0 on 3 for the same reason, right? 3 minus 3 is going to be 0. 0 times anything is 0. So you have 2 points on this graph. One that goes through -5, 0, and one that goes to 3, 0. Okay, this is obviously not the parabola because one of the points controls the vertex. Okay, but I just want to give you a visual that the parabola will go through these 2 points. Okay, so now what I'm going to do, I'm going to find the extra symmetry, right? Because parabolas are symmetrical, I know the parabola goes to these 2 points. If I find halfway in between, that's where my line of symmetry will be. Okay, so halfway between -5 and 3 should be right here. Okay, that's going to be x equals -1. Okay, so the reason I'm writing all this out is because if we know the line of symmetry is x equals -1, we also know the vertex has a x value of -1. Okay, so we don't know exactly what the y value is yet, but we know for sure the x value has to be -1 because the vertex has to be on the line of symmetry, right? So all we have to do is now plug this x value into the equation and get the matching y value, right? Equation, table, graph. If I know the x value, I can test, plug it in, get the matching y value. Okay, so I'm gonna do this on a calculator. I'm not gonna show it on the screen, but you guys can follow along with me. I'm just gonna type in -3/8. I'm gonna multiply that by a -1 plus 5. I'm just let the calculator do the work for me. Obviously, you can do some things in your head. -1 plus 5, close parentheses, open a new set of parentheses, multiply that by a -1 minus 3. Okay, so calculator does the work for me. I get a value of 6. So now this becomes -1 comma 6. That's where I know the vertex is. That's how I know where the vertex is. Okay, so it's on the extra symmetry, -1 comma 6. I'm going to move the vertex there. And as you see, if I move the vertex anywhere along this axis of symmetry, it still goes through those x-intercepts that I want, -5 and 3, right? So I want specifically here, -1 comma 6. That's the vertex. Most important point to find on the parabola. And then we already know one of these is the x-intercepts, so then it's symmetrical over the other side. So we're good. Okay? So that's how you graph these.